Hello everyone, this is 4 a.m. in the morning, and yeah, as you can see on my screen here, I've got what do you call it, a POC that I prepared for the OBD integration with Lizzie is now ready. I have set up certain basic things like getting the speed, RPM, and the engine load from my car's ECU unit using the OBD port that is there. So um, what I have here is basically I have got a screen that I've created. I've got a OBD simulator. This application which is running on my phone, it simulates OBD connection, or rather it simulates an OBD device which can talk over a Bluetooth connection. And I already have a ELM327 adapter installed in my car, so I can talk to the OBD board on my car or my ECU on my car using that ELM327 adapter. So what I needed to do was I needed a way of simulating that same kind of setup here in my room, because I cannot bring my car into my room. So I just downloaded this application. I paid something for it. I mean, yeah, this is the first time that I paid something, or I downloaded a paid application for doing my development work. Most of the times it's like free stuff that I use, and I also give away free stuff for my for the code that I write. So anyways, yeah, let's just talk about this particular thing here. So because the code, when it gets uploaded to the Raspberry Pi, it's quite heavy, primarily because of these controls. So the sketch is now around 60 MB or maybe 58 or something, but yeah, it's quite heavy. So I just have everything set up. I have it running here, and what happens is basically I've got this code here in front of me. So there are certain things that happen in a sequence. So first of all, you call the initialize. So what initialize does is basically send some AT commands to your ECU. So in the communication protocol is saying that we used to use during the modems days, when we used to have the modems, we used to send the AT commands to those modems, and the protocol is RS-232, or the specification is RS-232, which is what defines how to communicate over a serial channel. So basically it's used in a lot of things, and it's an it's an ancient specification. But so here, I mean, these are the AT commands that I'm sending to initialize. So it's like ATZ, which initializes the communication. Then there are certain things, because the software that I'm using expects me to specify those parameters when I. So I'll demonstrate it here. So this is the software that I'm using. It's an ECU Engine Pro. So it simulates an ECU, and it expects me to send these commands in the initial time. So it reset the OBD-II adapter, then it sets the protocol, then it just sends a header. So basically I want, if I want to have a header appended to every request and response, I'll send this I'll set this flag to 1, otherwise it's 0. And then the formatting of the response and request. So if I want to append the size of the payload and those kind of things, it's most of technical stuff, but uh, the good thing is I've got it up and running now. What I have here is basically this is the command that I sent during the initialization phase. Once the initialization done, these buttons are enabled. So I have already initialized it. I can try to demonstrate by stopping it and again, but I don't want to do that. So let's just stop this. Let's give it a try, because uh, I have a small problem here, is that that's this Bluetooth thing is not very stable on Windows 10. So if it breaks at certain points, it's really difficult, because I've been struggling throughout the night to get it up and running. and when it breaks, when the Bluetooth stops responding, it stops, and then you have to do a lot of stuff. Sometimes I just need to restart my Raspberry Pi and my Visual Studio to get everything cleared out. But that's probably because the build that I'm using uh, for Windows 10 IoT Core is insider build, which is, I mean, pre-release build. It's not a stable build. But anyways, I mean, still, it's like I'm trying to set it up. I'm running. It's running. Sometimes it breaks because the Bluetooth is not connecting properly, or maybe it's there can be a lot of reasons behind it behaving in a strange manner. One of them being my phone's Bluetooth protocol or the way it communicates. So I seen that it keeps on refreshing itself. So it's quite difficult to nail down the exact reason. I'll find out the exact reason. But right now I'm just more focusing on getting this thing. So here it is how it looks when it starts up. Just initialize. So when you initialize, it's gonna send some commands to the modem or to the device. Yeah, you see, these are the commands that I've sent. So, and then I'm logging the response here as well. So if you see, first of all, I start with sending an ATZ commands, the modem or the OBD device simulator running on my mobile phone sends a response with the version of the ELM protocol that it's using. Then I send an ATSP6 command, and the device responds with an OK, and so on. It goes on. And now I've got my functionality ready wherein I can start getting the speed. So when I click on get speed, it's going to give me 100 kilometers per hour because that's the speed that I've set up here on my mobile phone, which is here, the middle dial. I can change it. I can make it 120, let's say 180 maybe. So I've set it up to 180 now. What I'm gonna do is I'm gonna hit the get speed command again. Yeah, so it's 190, which is what I have on my mobile. So it's 190. I can change it back to something else, maybe 90. So when I click on get speed again, it's going to get the speed as 90. Yeah, so far so good. The same way it applies to the engine load. All this engine load, although right now the simulator that's running on my phone sends a fixed value, so it sends a fixed value. The response that you are looking here is basically a value that is sent by the ECU, but I have to convert this value. So I'm using this article from from Wikipedia to understand how or in what format the values are sent. So if I look here, I've got this engine load. There is an engine load. Yeah, calculated engine load, which and then this is a value from between the range of 0 to 100. It's a percentage value, and then this is the formula that you use. So you whatever value you get, you multiply it by 100 and divide by 255, and then you get the value, the exact engine load that is there on the. Then the same way you have got the engine RPMs, which are like this. So you just get engine RPM, and this is the formula that you use for calculating that RPM. Now, what I see here is if I show you my code here, or yeah, this is so I this is my code. I just get those hexadecimal values from the OBD communication that's happening between the device and the phone, and then I convert them. And then I display them on this gauge. So if I get RPM, come on, yeah, so it's saying that my RPM is 750 rounds per minute, which is okay. So this thing is working. Now I can make it continuous. I can just hook up a timer. I can just make the timer tick at a specific interval, get the data and display it on these gauges, and then it's like a continuous thing which happens automatically at a specified interval. Yeah, so I'm happy. The previous demo that I created for this OBD-II was basically a simulator which was running on my PC. It was not a Bluetooth simulator. It was running on my PC, and I was just trying to get hold of the data using the serial simulators or serial port um, simulator that I downloaded from internet. It's a free software which creates what do you call it, a virtual tunnel kind of setup wherein you have got two artificial COM ports created on your machine. So you feed data from one side and you receive data on the other side, just like that. And then you hook up your OBD-II simulator that I downloaded from a PC. You just hook it up on one end and you just send your commands from other, and then you receive the response on the other end. It's like yeah, it's like a virtual setup. But this thing is, I mean, it's apart from this software. I mean, this software is not connected to an ECU, but the communication is real. So when I have a real ECU, basically, obviously, you know, the protocol, that the communication mechanism, everything remains the same. So this POC that I created is like the real thing. So I can just take this code as it is. I can put it into the actual Lizzie code base that I have, and then uh, it should be able to communicate to the vehicle's engine control unit and get the data out of it. Obviously, I will just need to change the device that I'm going to connect to. So right now I'm just connecting to this device here, which is my phone's Bluetooth. Later on I can change the name, or I can set the parameter, and I can just communicate to a different device from here. When I set up the devices here, I can just send up whatever device that supports. Obviously I would need to pair my Raspberry Pi with my car's the ELM327 adapter that's installed in my car. But that's just a piece of cake. It's very easy, not too difficult. I guess so. That's all for today. It was good. It's time for me to get some sleep because it's 4 a.m. in the morning, and I've got an off. It's my working day. It's a working day for me tomorrow, so I'll have to make sure that I just uh, I'm in a condition to go to office and do some work there as well. So yeah, it's good. It's really cool, and it's really interesting so far. Let's see. Uh, Please leave your comments below and let me know if you have any suggestions, or maybe anything. Just if you have any inputs, just let me know. I'll be really happy to take a look. Thank you so much.